here, focus here. So first I will explain you the construction how the device is created. What is the construction behind the junction field effect transistor? I will explain you what is that device. Then I will explain you the definition of junction field effect transistor. If you understand both the construction and definition, then I will tell you why they have given the name field effect transistor only. What is the reason behind why they have named it as field effect transistor? So in order to understand this, you should know PN junction diode, forward bias, reverse bias, and some concept regarding basic concept regarding transistor. So let me explain you the construction of this device. Consider this as a rectangular shape. However, it is in rectangular shape only. Just assume that you guys are occupied on the bench. What is that? Rectangular shape. So this device consists of a rectangular bar. We call it as a bar of shape that is made up of silicon. The complete rectangular bar, the complete rectangular shape is made up of what? Silicon, which is of N type. Which is of what type? N type silicon. Just assume that you guys are available on bench that is rectangular shape. That completely is a N type silicon bar, N type silicon rectangular bar. If it is N type silicon, what are the majority carriers here? What are the majority carriers in N type? Semiconductor, electrons. So electrons are the majority carriers. Next step, what we have done, on both the edges, on both the sides of your rectangular bar, we have diffused p-type semiconductor material. Focus here. What we have done? We have diffused. Diffused means we have added p-type semiconductor material on both the edges of the bar, on both the sides of the bar. P-type semiconductor material means it may be a boron, it may be a indium. We are adding boron, indium on both the sides of bar. Understandable? It is a p-type semiconductor material now. Now this is also p-type semiconductor material. We have done. Now here I wrote B and C. It's your wish, whatever you want to write. S, K, K, S, A, B, C, D, whatever alphabet you take. This completely is channel. This complete, whatever the portion is there. Here I wrote N. This completely it is a channel. That is N channel. Why N channel? Because completely this material is made up of what? N-type semiconductor material. This complete space, whatever the space I am fading, whatever I am doing this, that is channel. So from here to here it is channel. Now here I wrote S, there I wrote D. Focus here. These are the two electrodes. These are the two terminals. Terminal means treat like a hand, treat like a leg. Door is one terminal, window is another terminal. You can enter from the door, you can't exit from there because you will get a harmful things. There's a like this. These are the two terminals, two electrodes of this device. This is called as source and this is called as drain. What is one terminal? Repeat it me. Source. What is that? Drain. These are the terminal electrodes, contact, potential, where you can connect the potential, where you can apply a potential. Now let me tell you what is source. Source is nothing but always negative pole of the battery. Battery means in your remote cells you have a battery. Say sir, you have minus and plus. On one end you have minus, on another end you have positive terminal. So source, always negative pole of the battery will be connected to source. Vice versa, always positive terminal of the battery, positive pole of the battery is connected to drain. So it means source is a negative terminal, drain is a positive terminal. One more definition. the majority carriers, what are the majority carriers here? Electrons. They will enter to this bar. They will enter into here in this space, in this bar through source terminal. Majority carriers will enter into the device, will enter into this area from source terminal. Majority carriers will leave the bar through drain terminal. Understandable? Source is the negative terminal of the device, drain is the positive terminal of the device. Always negative pole of the battery will be connected to source. Always positive pole of the battery will be connected to drain. What is this area? What is that? Channel. Where your majority carriers will move, they will flow. Here they will move. This is nothing but channel. From B to C it is a channel. Which channel? What is it? N channel. Understood? Got the point? The third point, what we are doing, this p-type semiconductor material and this p-type semiconductor material, I am joining. See here, what I have done? I have joined both the metals. That will form a terminal, one more terminal, one more end of the device. That is nothing but gate. This is nothing but your input terminal. The third terminal is what? Gate. How it is formed? By joining both the p-type semiconductor material. You can see here this line is going here. From here I have drawn a curve. Means these are not connected. The curve, then again it is going to here. Both the p-type semiconductor material are joined by wire or any kind of metal, anything. That terminal is what? Gate. That is the input terminal. Input terminal is what? Gate. Understandable? Say some. So this is the construction. So whenever you are drawing this diagram, whenever you are available on a bench, that is rectangular shape. Imagine that as a rectangular shape. N channel. In the center you write N. On both the sides you make P. That will become PNP. PNP. This makes one junction. This makes another junction. PNPN. Understandable? And whatever above this is nothing but what? What I have? Depletion layer, depletion region, space, whatever you call it. Clear? Understandable? This is the construction of the device. How device is constructed. Clear? Now let me define what is junction field effect transistor and why they are calling it as a field effect transistor only. So focus here. By using this diagram only, I will define what do you mean by junction field effect transistor. JFET is a voltage operated overall voltage controlled unipolar device which has three terminals. How many? Three terminals. What are those three terminals? Source, gate, drain. Source, drain, gate, whatever you call. Three terminal. What is this completely made up of which material? Silicon. Commonly semiconductor. So JFET is a voltage controlled overall voltage operated unipolar three terminal semiconducting device which is available in two configurations, N channel and P channel configurations. Understandable? Clear? Say so. I will repeat one more time. It is a voltage controlled overall voltage operated unipolar. What do you mean by unipolar? What do you mean by unipolar? Uni means singular. Unipolar device means current flows only one direction, from positive to negative, anode to cathode. It is a unipolar. Now how many terminals it has? Three terminals. You can mention them: source, gate, drain. Source, gate, drain. Three terminals. What is it is made up of? Semiconductor material. And it is available in two configuration, N channel and P channel configuration. Clear? Got the definition? Now let me tell you. I have mentioned that JFET is a voltage controlled or voltage operated device. Now I will tell you the reason why they are calling it as a voltage operated or voltage controlled device. In order to understand that, you have to recall the topic of transistor. What? In order to understand why we are calling it as a voltage operated device, you have to recall the topic of what? Transistor. But you won't recall. You guys are busy. You won't come to classes. You will enjoy. Let me recall for you. What do you mean by transistor? Focus here. It's an important point. Concentrate here. In common emitter configuration, in CE configuration, what is IB? What do you mean by IB? Just tell me what is IB? B means base. IB is base. In CE, it is input current. And IC, what is IC? C means collector. It is a collector. It is output current. And in CE configuration, in cutoff region, IB is how much? Anybody in the class? I will tell you. IB is 0 and IC is also 0 in cutoff region. In saturation region, IB, if you increase IB, IC also increase. If it is somewhat 40 microampere, it will be 10 or 15 milliampere. What I am going to tell you is that, listen here, IB is 0, IB is what? Input current. What is IC? Output current. Input is 0, output is 0. You are increasing input, output current is also increasing. Let me tell you, so here I can write I is directly proportional to I. Say some commonly. I in is directly proportional to I out. In case of CB, IB is directly proportional to IC. Means the BJT, the transistor, is a current controlled device. What is that? Repeat with me. BJT is a current controlled device or current operated device. Because current is directly proportional to current. Input current depends on output current. Have you seen I movie? I remember like that. Who is the hero of I? Vikram. Like that you remember. I is proportional to I movie. BJT means I move. Clear? Now listen here. Now let me explain you why JFET is called as a voltage operated device. Focus here. Now what is this terminal? Gate terminal. What it is? Gate is input terminal. So here we are applying the potential. Here we are applying certain kind of voltage. Means your input, don't know. Your input is responsible for causing a change in output current. Your output is your drain current. We are applying certain potential. Where we are applying certain potential? At the gate, at the input terminal. That is nothing but voltage. That is causing a certain change in output current, drain current, which is causing a certain change in drain current. So voltage, input voltage is responsible for causing a certain change in output current, drain current. Input voltage is directly proportional to output current. That's why it is a voltage operated device. Voltage controlled device. If input is 0, drain current 0. Like this. Voltage is directly proportional to drain current. So, clear, understandable? Why we are calling it as a voltage operated device. Now let me tell you why we are calling it as a field effect transistor. Why they have given a field effect transistor. So, an electric field will be applied at the input terminal. Electric field means potential only. We are applying an electric field at the input terminal, which is causing some change, some response in the output current drain current. Because of that reason, we are calling junction field effect transistor as, we are given a name, they have given, scientists or someone, they have given a name, field effect. Field effect means electric field. Where we are applying electric field? Gate, the input terminal, which is causing the changes in the output. In common you say output. Here output is drain current. Understandable? So electric field is making a certain changes. Electric field is responsible for those changes. That's why they have named it as field effect transistor. Clear? Understandable? I will repeat one more time. In transistor, in bipolar junction transistor, base current is directly proportional to collector current. I is directly proportional to I. In is directly proportional to IO. That's why it is a current controlled device. You can control the current. You can't control the voltage. Current can be controlled. That's why it is a current operated, current controlled device. Now JFET is voltage operated device because input voltage is directly proportional to output current, drain current. That is nothing but electric field. This beam is nothing but electric field, potential. That's why it is a voltage operated device. And though they have given a name, field effect. Electric field is causing a change in the output, causing a change in the drain current. Understandable? Say sir.
Yes, sir.
Say sir.
Yes, sir.
Clear? Yeah, you can pause it. Clear?